All right. Let's finish up with chapter 15, which is the second part of 15B and C, kind of combined. So the idea is more like we're looking at the measure of the spread. So in statistics, there's a measure of the center, so the mean, median, mode, and with the spread, you look at things like quartiles, interquartile range, and range. First is looking at what a percentile is defined as. Then we can move on to determine the 25, the 50, and the 75 percentile, which represent your first quarter, your second quarter is your median, and your third quarter your 75%. All right, so what you have is the value p of x, where you must have a certain value. So let me rephrase that. So you have your integral, which is the area under the curve. The area under the curve is a probability, so it is a percentile, and that's your q value that you have on the right. Now the value p is your upper limit, or your vertical line on your marking that where you stop your area, and that is your percentile that you are after. Notice the lower boundary is negative infinity. You have to start from really from across the whole domain from the left hand side. Usually your hybrid function will be zero on the left somewhere, so you won't have to start your integral all the way that far, but that's what you should do in a general situation. So here we go. Q is a probability. Again, it can be it's a decimal that represents a percentile or a fraction over 100, and so on. So we have your 50 and 75. So respectively, you have those values for Q. You will use a CAS to solve that in most situations. Okay. Notice if you were to do Q equals, how does it work? Yeah, if that was 1, that would be your infinity here, because the whole domain has to be equal to 100%. All right, so let's look at a question. So you have a hybrid function. That function represents the number of minutes for phone calls. Okay, so it's a random variable, and it follows this probability density function. For this question, we need to answer different percentile in part A, B, C. Okay, so what we do here is to just solve all those different questions. We're gonna leave the percentile unknown as a fraction of 100, and the upper boundary as a variable as well. We'll substitute the function f. Now it should be from negative infinity, but because for negative values the function is 0, we can start a function from x equals 0. So we substitute the function, then all you need to do is anti-differentiate this function. You have your boundaries from 0 to a. You apply the formula, and what we're going to do is rearrange it to make a the subject, because we want to express the upper boundary, the duration of the phone call, in terms of your percentile. There's a bit of working out here using transposition, also your exponential and log properties. So here we have our expression of a in terms of our percentile. So keeping this formula in mind for the whole of the exercise 6. So for part A, we want 90% of the phone calls last less than a minute. So we want to find the value of A. We use the formula that we had before. So Q is going to be 90. We evaluate that, use a CAS, and it's 6.91 minutes. So that's what it needs to be. Okay. We can also do that on the CAS. Weird screen. That's an old. That's the other calculator. But anyway, that's going to be really similar. You define your function. So when you write you use in the next line your solve function, and you write your integral with the function f. Your upper boundary is a, and that is the variable you need to find out. And when you solve it, you get the same answer. All right, next one. This time is 50%. We need to find the new value of a. So we substitute q from the general formula with 50. We get 2 less than 2.08 minutes. Again, this is the screen using a CAS calculator. So that was before for 90. Here it's for 50% or 0.5, and we get the same answer. Answer 2.08 minutes. All right, 75%. Substitute q by 75, we get 4.16, which is less than 4.16 minutes. Same again, using a CAS, you should get the same answer. Now we do the 25%, so I'm just gonna speed up. All right, you may want to pause your video if you want to have a look at this working out. It's also in the textbook. It's a work example. Same with the CAS calculator. So in your equation you write 0.25. Now we've done a 75% and a 25%, which will lead to what we can do is determine the interquartile range. So let me go back into order. So when you have your 50 percentile, that's your median value. Notice that the probability on the left, less than the median or greater, is also 50%. So you might use either, depending on your function, but it should be the same. The interquartile range is going to be the difference of your 75 and 25th percentile. So it's your Q1, Q3 minus Q1. Your median is Q2. Yep, that's fine. The range is your maximum minus your minimum, and that's coming from your function. You can read it from the screen, from the graph, or from the range of your function. All right, same question. We want to find the median. So find the median is your 50th percentile, which is what we calculated in the previous part. So you might have to go back a few earlier in the video. It's an exact value. It's 2.08 minutes. The interquartile range, we do the difference between the two. That gives us 3.3 minutes. That gives us an indication of a spread. Okay. Similarly, the standard deviation also helps with the spread. Okay. I think, yep, the range. So with the range, you look at your function. You can, let's say we look, the largest value is because of the restriction of the domain. The y-intercept is actually your highest value. Notice how the exponential has a negative. It's a decreasing function. So the highest value is when you have 1/3. And then as you get in a negative value, that's 0. You do the difference, and that gives you the range. Sorry, let's go back. That gives you the range here. All right. Now to find the mean, the variance, and the standard deviation, it's from previous part 15b. So we need to find the expected value of x, find the expected value of x squared to get the variance. Expected value. So we multiply our function f by x. We need to go all the way to positive infinity. All right, so you're going to need to use a limit notation. Here they use infinity, but that's fine. We'll see how it gets there. And you anti-differentiate. You can use a CAS. I don't know if it's going to deal with infinity. Anyway, we've done that before. The expected value is 3. To find the variance, we're going to square this one. But first we need to find, So that's why we square the expected value of the variable x. We need to find the expected value of x squared. Again, so that seems to work, yeah, infinity using the cas. So you can recall the previous function and edit the x to x squared. That gives us 18. So that's going to be 18 minus 3 squared, and we get a variance of 9. We square root that, we keep the positive value, the standard deviation is therefore 3. Alright, remember the mode. The mode is the value that repeats the most. So the peak here, where the function is the highest, think about your function. Again, your function is your probability, so it's the chance of happening. So here at that highest, at your maximum value, what you read is actually a probability, kind of. That's for discrete random variable, but I'll just make the analogy. You need to go down to the x-axis to read out the mode. So let's do an example. You have your function, just sketch the function. Here is a cubic over between 0 and 1. The rest is going to be 0. So for the negative, probably again use your skills that you have. You differentiate to find your turning point. So you have two stationary points at 0 and 2/3, and we know that when x equals 0, it's a local minimum. So we substitute x equals 2/3 to find the y coordinate. And what we can do now is having, so what did we have before? So that's a local minimum, and here we have a turning point here. Okay, so here when you have your highest value, which is for maximum value is 16/9, and the mode is 2.3. Okay, so with the maximum we can determine the range, and that's pretty much it. So here again, I made the analogy that it is a probability, but it's not really. It's only for discrete random variable. Remember, a probability for a continuous variable is actually an area under the curve. So that can be peak anywhere as long as the whole area over the whole domain is equal to 1. It doesn't really matter how high it goes. Okay, so we've done that. We with this function, it's a cubic, find the mean, the variance. So again, it's a little bit of processing and doing anti-differentiation. So we multiply by x. That is a quartic. You use a cas, or unless you expand it, but just use a cas. Remember, from over the whole domain of the function, it's a probability density function, so it equals to 1. Now we multiply by x, that gives us 3/5. So that's the expected value of x. We want to find now the expected value of x squared, so we substitute here with x squared down here. That gives us 2/5. We minus the expected value squared, and we get a variance of 1/25. You square root that, that's 1/5, which is the standard deviation. Okay, this is new to this part, the median and the interquartile range. So for the median, we need to find off 50th percentile. For the interquartile range, it's the 25th and the 75th percentile, and do the difference. Again, you don't want to do a cas, so you integrate from because your function starts at 0, the rest is 0. You start from 0 to a. A is the variable we want to find out, and that integral needs to be equal to 0.5. That's for your median. We do that for the lower quartile, 0.25. We do that for the Q3 or the upper quartile, and those two values we subtract to get the interquartile range. So to summarize, we have the median, Q1 and Q3, we do the difference, and that gives us the interquartile range. And then we move on to normal distribution in the next chapter. So see you later.